Everyone, happy Monday. I hope you all had a really good weekend. Can you believe we only have 9 school days and then it's a Thanksgiving break? I can't believe it. So you guys have a full week of school this week, and then next week you only go Monday, Tuesday, Wednesday, Thursday. So that's where the 9 came from. So that's kind of exciting. Okay, so today we're going to continue with same thing we started on Friday. We're talking about interpreting slope and y-intercepts, kind of the second half of Unit 4 here. We're looking at more like real-world, like application-style problems. So if you go to Canvas and you're on my home page, click on the modules page. Now this modules page does look a little different, but if you go all the way down to the bottom, here's what you should see today. So we're going to practice some more about looking at slopes and y-intercepts and what do they mean when we're talking about like real world problems. And then you have a like really short exit ticket for today. So be sure and do that exit ticket. So this assignment here, I'm going to give you a complete, incomplete. I have to actually leave student view for you to see this. And then I'm going to put the exit ticket grade in the grade book. So this is for you to practice to get ready for the exit ticket, basically. So what you do is you click here, this type of assignment, click here. Now yours also has a submit button on this side, but mine won't let me see the submit button. If you click here, it's going to open the file in a new tab, remember, so that you can actually work out of it because it's just way too small in that other tab. So here's what you've got. You've got 10 problems. Oh, this is not loading correctly. Let's give it a second. I don't think it's... Oh, you know what? This is not the correct one. I changed this and it did not update. I'll be back in 2 seconds. Okay, so now this is the updated one. So what you have is 10 problems, and I just want you to work 7 of them. So you're going to type your answers directly on to the card here where it says type. So I'm going to work like 3 of them probably, and then you can choose which ones you want to work. But I'll work 2 or 3 of them with you here to get you started. I only want you to work 7, so maybe work the other 7 that I didn't work. It'll work out that way. Okay, so let's talk about this one. So Ishmael, he started the day with 120 followers on TikTok. Now he uses this equation to determine the total number of followers, F, he will have after a certain number of days, D. It says, what is the slope of the line? Well, I don't see a line, right? They didn't give me a picture on this one, but I have an equation. So there's several things you could do here. You could come over, remember, Desmos is linked on the side over here. Now your side does not look like this. I have a lot more options that you do. But you could come over and click on Desmos and open that up in a new tab. And you could graph this problem, and that's going to give you a picture. Now, I don't know. Let's see if Desmos lets us do F is equal to, we have 15B plus 120. Yeah, it will. Last year, Desmos didn't like if you didn't use X and Y. It looks like they've updated it. So we could zoom out here. Okay, so there's our picture. But they want to know what's the slope of the line. So if you wanted to, you could come over here with the graph. You could rise and run. Or we have an equation here, right? So let's think about this. This is solved for one of our variables. So this is as if it's solved for y equals mx plus b. So we know our slope has to be how much it's changing. Remember, slope is rate of change. That's why it's called rate of change, because it's how much something is changing, an amount is changing. So his followers are changing by a certain amount every day. Well, that should be the value in front of D, remember, because y equals mx, m is in front of x. This is where our slope sits. So the slope of this line is 15. Now it says, what does the problem represent in the context of the problem? So remember, slope is rate of change. How much is something changing? And this is changing based off of his followers are changing after a certain number of days. So the slope tells you how much his followers are changing every day. So this is telling us that he is getting 15 followers per day. Now, per is a word. When you see the word per in a problem, you should think slope. That is the number that you're multiplying by the variable where slope sits. So per is one of those words where you think, oh yeah, because rates are usually pers. Think of miles per hour. That's a rate. That's a speed. That's a rate of speed. So per is that key word that we like to think, oh, that's talking about our slope here. How much is this thing changing? So it looks to me like he has, see, it says he started the day with 120 followers. We could see that on our graph. So over here, where is 120? Oh, it's right here. And it looks like, so that's our y-intercept, right? Because it's mx plus b. Our b value is our y-intercept. That's how many followers he started with. Then he's increasing his followers from there. So by like day, what day is this? So this is going from day 0 to 50. So on this day, this is maybe like day 10 or something. He's got how many followers? Looks like he's up here. We could trace this up till we get to 10. Yeah, it looks like he's about 270 followers by day 10. So his followers are increasing. The slope is how much he's getting, how many new followers he's getting each day. Okay, let's look at another one. So this one, they gave me a picture, but they didn't actually give me an equation for this one. I'm not seeing an equation, but I have the picture over here. So Farmer Alley had a well on his property that was 200 feet deep. When the well went dry, he hired a company to drill the well deeper. The graph represents the depth of the well based on the number of days the company drilled. What is the slope of the line? So here's the depth of the well right here. It says that the y-axis is our depth and the x-axis is the number of days. So remember, like I told you in the other notes, your axis labels will be super important if you've been given a picture. It says, what is the slope of the line? So let's think about this. So this says our line starting here at 0, negative 200. So let's think about this for a second. This isn't what our problem's asking, but this is a good one. This is the y-intercept, right? Negative 200. So this is modeling the depth of the well. So, and think about, this is the number of days. So my y-intercept here is 0, negative 200. So when my days are 0, my depth of my well is negative 200. Now we don't usually think about measuring depth with negatives, but we can when we're talking in algebra, because what this is saying is, like, if the depth of your well is here at the origin, well, that's 0, 0, right? So that's 0 days and my depth is 0. That's hasn't even been dug yet, right? So sometimes when we talk about distance going up and down, we do use positive and negative in algebra. So this is actually a picture of the well getting deeper and deeper and deeper and deeper. So on day 0, before he hired the company to drill the well deeper, his well was already at 200 feet deep. Then after 1 day of digging, the well looks like it was about maybe like negative 275 feet. So they want us to figure out the slope. So it looks like on day 2, the well was at like negative 350. So we need to figure out the slope of the line here. Well, here's one point. I need another point so I can figure out how much it's changing. So what if I use this point right here? So remember, it's rise over run. So how far do I have to rise up to get to this point? Well, I go from negative 350 up to negative 200. So my rise is negative 350 minus, and then I go up to 200. So it'd be minus negative 200. So I go from negative 350 all the way up to negative 200. You can also just think about it as, what is the actual amount that we were going to rise? So if you're going to use a slope formula, you subtract your y values on top, subtract the x's on the bottom. But for this one, well, I can see I've gone up how much? I went from negative 350 to 200. That's a difference of 150. That's really what I need is my difference. Then I look and I say, well, okay, how much did I run? So I ran from this point to this point. I go up, I'm running from 2 over to the origin, which is 0. Now, we're going to come back and say, okay, is this line positive or negative slope? It's going down, right? Because the depth of our well is going down. So it's got to be a negative. Well, negative 150 divided by 2 is negative 75. So the slope of this line is negative 75. So what does it represent? Remember, this is rate of change. It's how much deeper the well is getting each day. Every day they must be digging 75 feet down. That's what the negative really stands for, is going down. So every day the well's getting 75 feet deeper. Boom. Day one, that's what we said, right? It looked like it went from 200 to about negative 275. But this was a better point to use because we could clearly see it's at negative 350 and comma 2. So that was a good question. That was a tough one. So you had to remember that it was negative. We need to understand why that it's going down like that. Why does it start at negative 200? Because you're drilling down. You'll see these negatives used like this when they're talking about oceans too, like diving below the surface of the ocean and stuff. Okay, I don't want to do this one. I think I want to do one. Let's see. I want to do number 6. Actually, I think I want to do number. I think you can do it. I want to do number 6. So Jose is an electrician. He charges $65 per hour for electrical repairs, plus he charges $100 service fee. So the graph represents the total charge for his services, C, after working H hours. So notice they told us that C charge is on the y-axis, and it says our x-axis is hours. What's the y-intercept? Well, that's easy to find. We just look on the graph, right? It's over here. Here's our y-axis. It looks like it's 100. Okay, so our y-intercept is 100, or we could put it as an ordered pair, 0, 100. What does the y-intercept mean in the context of the problem? So what is this 100? Well, I noticed they mentioned 100 up here too. It says he charges $65 per hour for electrical repairs plus a $100 service fee. Okay, I'm going to do this over here. So what's the 100 represent? Do you think it's the service fee? Let's see if this makes sense. Remember, service fee is something you're charged before someone even does work at your house. They come out, they charge you the service fee just for showing up to your driveway. So this is saying, remember, it's 0, 100. So remember, the x-axis is our hours. So at 0 hours, our charge, that's our y-axis charge, is already at $100 at 0 hours. So when Jose has worked 0 hours, he's charging us $100. So yes, that's what it represents. It's the service fee. A lot of times, your y-axis must be service fee. Your y-axis and your y-intercept is going to represent that starting cost. Think about the Desmos activity that we did on Friday, where we were talking about t-shirt orders. And so there was a design fee, and every time that was our y-intercept. So this was a good problem to think about that. Okay, so you need to pick 7 to work. I've already worked 3, so I would like for you to choose at least 5 that I have not worked. So if you want to count these 3, you can count 2 of them, but work 5 that I have not worked with you. So work a total of 7 problems. Hopefully this will get you started, and then go over and see if you can do the exit ticket and see how you do on that. So remember, on the exit ticket, when you come back, I'll have to go here and go back into student view. But when you go in to do the exit ticket, remember that you get 2 attempts. It may not even be unlocked, actually. Over here. But so if you take it and you don't score well the first time, retake it, because it's going to let you do it twice in a row. So make sure you do that, because that will go into the grade book.